All right, so this year, our test is on Monday. You guys already know that. We talked about the number of questions in each part and how the multiple choice, you're gonna run out of time. It's okay. You just need to pace yourself. There will be some questions that are way easier than others. So if there's one that you're just like, what? You can skip it and come back to it. It's all on the calculator. I think at the end it'll tell you what you haven't answered yet. Okay, so we're going to start focusing on the free response questions. And like I said, on Friday, there's going to be 2 calculator questions there, number 1 and number 2. And then those will disappear from your screen, and you'll get 4 more. So after 30 minutes, those will be gone. You'll get 4 more for 60 minutes. You won't be able to go back and look at the screen that has those questions on it, but you will be able to write in your test booklet if there's something else you just like, oh yeah, I should have said this. You can write that. Okay, so I have some tips or some strategies for the FRQ. One thing I'm not sure if I told you about, sometimes like you need part B to answer part C. And if you don't know how to do part B, all is not lost. You can make up an answer for part B. So if it was asking for, I don't know, the average rate of change or something, and you can just make up an answer for that and then use it on part C, you can still get your point. So the person grading your test will like rework part C with your answer to make sure that you earn those points. So that's something to keep in mind. Always show your steps. Sometimes on this test, you get points just for showing your test. That wasn't true on AP pre-calculus. You got 1 point and it was either all or nothing. These points are more spread out, and sometimes just writing something down gives you a point, even if it's not the final answer. All right, if it's non-calculator on part B, you're gonna leave it messy. You're not gonna waste time figuring out what 5 times 7 plus 2 times 3, whatever. You're not gonna waste your time figuring that out. You're just gonna stop. Write a unit though if it asks you for that. And then you can decide the order you want to do these. So you'll have to do part A first. So if you want to do question 2 before 1, it's fine. Just make sure you're on the right page in your answer booklet. And then when you get to part B, if you really love doing differential equations, and you can just see if there's one of those and then do that one first if that's what you want to do. So these are some verbs that you're going to see, and just try to remember what you're supposed to do. So whenever you're estimating or approximating an average, a derivative, you have to use an average rate of change. That's how you approximate a derivative. If you want to approximate an integral, then you're going to use Riemann sums, or you're going to use the area under the curve. All right, and then we all know the nut strategy. Make sure that you do that whenever you're interpreting. Whenever you're doing something in the calculator, and we'll talk about a calculator question today, you have to show your setup. You can't just get it from the calculator and write the answer. That won't get you any points, so make sure you provide the setup. All right, if it tells you to identify or indicate, you don't have to give an explanation. If you're told to explain or give a reason, you obviously have to give some kind of reasoning, some kind of rationale. Justify requires formal reasoning, so you'll have to use a theorem or a definition for those. All right, and then here are some things you need to know cold. The flashcards for the derivatives and the antiderivatives, study those. We might start doing them in class if we have time, just going through them. But another thing that you're going to need to know is the area of two-dimensional shapes. So I feel like you know these, but let's just jot them down to make sure. You don't have that paper from Friday? All right, so rectangle, super easy. Triangle, almost as easy. Trapezoid, not so easy. Okay, so it's kind of like a triangle. So it's still 1/2, and you still multiply by the height. But the bases, you have 2 bases that you add together. Yeah, good job. And I feel like you guys all know circle. So somewhere on your test, you're probably going to have to use one of those areas. If it is a three-dimensional volume, then you will be given the formula. So like when we did related rates, there were like stuff with spheres, you would be given that formula, or a cone. So you don't have to worry about memorizing those. Okay, you do need to remember, we just learned this, so hopefully you do, the disk, finding the volume for a disk, using disks and washers. All right, so because they're circular, you do have the pi, and you're going from something to something. We'll say A to B. And if it's a disk, then it's just going to be whatever the radius is squared. So what do you have to do on washers? Good, you have to subtract a circle away. So you still have the pi because it's definitely a circle, but it's going to be capital R squared minus little r squared dx. And then I'm going to start, and I didn't do it on the first one, I'm going to start putting the functions in parentheses. And then the dx or the dy or whatever on the outside. I was reading some stuff that other calculus teachers were writing, and just like, it's not required that they're in parentheses, but sometimes you can write it in a way without parentheses that is wrong. So today, and when we're practicing derivatives from now on, we're just going to go ahead and put the integrand in parentheses and then the whatever on the outside, dx or dy on the outside. Okay, what about the average value? What has to be in the front of average value? Good job. And then the last class, I heard a lot of people talking about displacement and total distance and net distance. Net distance and displacement mean the same thing. So it's like the difference from when the interval started to when it stopped, not counting all the movement in between. How do you find that? It's an integral. Yeah, how do you find it? Absolutely. The velocity. So we'll put v of t in parentheses dt. All right, and what about total distance? Nice job. Now, I did hear some people also saying when you do that in the calculator with absolute value, your calculator really thinks. So it's okay. Don't panic. Just let it do its thing, and you should be fine. All right, and then the definitions of continuity and differentiability. I personally haven't talked to you about it. I'm sure it's been on your multiple choice a little bit, but it's possible that you might have to justify that something is continuous at a point or whatever, or a function is continuous. So you are going to need to know how you prove continuity. Do you guys remember? It's been a while. It isn't the intermediate value theorem. It's the limit as x approaches whatever you're proving it's continuous at from the left of f of x equals the limit from the right. And then it does have to equal one more thing.
Equals f of that.
F of a. Good job. Perfect. So there's 3 parts. It's a 3-part definition of continuity. Bless you. Okay. And then for differentiability, the function has to be continuous. Now, a lot of times it tells you it is, but if it doesn't, you have to use that definition of continuity. And then what else? And that involves a limit has to happen for the function to be differentiable at that point.
Well, like, are we talking about the actual, like, graphical function, like the not the sharp turn?
Not the sharp turn.
And no poles.
No, that's a continuous. So not the sharp turn in like justification ways, sorry, is that the limit of as x approaches a from the left of f prime of x equals the limit from the right. The slopes match on the left and the right for the function to be differentiable at that point. Otherwise, there would be a sharp turn like she was talking about. Good job. You guys are doing great. Remembering stuff. I love it. Okay, so there are 6 free response questions. This is what they typically are. I cannot promise you that's what they'll be. They decide year by year. I can look at them and kind of try to make a prediction. But we're going to do each of these. The miscellaneous one, I think is might be a little bit more condensed at the end, and you guys might be taking other tests during that time. But I think we should be able to get through all the different types, and hopefully you'll feel super comfortable with them. The one we're going to do today is going to be the rate accumulation one. And it is usually calculator allowed. So a lot of times there's like a rate in and a rate out, and they're usually real life context. Oh my goodness. And then a calculator tip, and we did this before, I typically will like to make Y1 be the rate in, Y2 be rate out, and then Y3 is going to be Y1 minus Y2. And that basically is just the rate of total change. So like one we're about to do is about fish entering a lake. And so rate in is how they enter, rate out is how they out, and then when you subtract those, it's the rate at which the number of fish are changing. You guys are going to do one about being in line for an escalator, and so that subtraction is going to be the rate at which the number of people in the line is changing. So anyway, that's pretty helpful when we're doing these. Most likely at some point you're going to have to describe something, and so we're going to make sure you use units and context. And I highly recommend that you quote the words from the problem. That's how you don't get it wrong. If you say it the way they said it, then you're probably saying it right. All right, so we are going to do 2019 question 1 together, and then for your assignment, you're going to do 2018 question 1. They're both rate accumulation problems. Sure. Okay. So 2018 is all about fish. And so, 2019 is all about fish. So fish enter a lake at a rate modeled by the function E, where E is that function. Yeah, grab a calculator if you don't have one. And then they leave at a rate modeled by L. So we have a trigonometric function for entering. We have an exponential, kind of weird exponential function for leaving. And then, let's see, both E of T and L of T are measured by fish per hour, and T is measured in hours since midnight. All right, and so A says, well, let's go ahead and do what we need to do with the calculator. So as soon as I recognize that this is a rate in, rate out question, I am going to go to Y equals. Now you won't be able to write on your paper, I'm sorry, but I'm going to make, on the real test, I'm going to make rate in be Y1, I'm going to make rate out be Y2. right, and then I am going to go ahead and have y3 be y, oops, sorry, I hit the wrong button. All right, y3 is going to be y1 minus y2. So it is important that you remember how to get those y variables. So it's always alpha trace to get those. Okay, so let's see what we need to do. A says how many fish enter the lake over the 5-hour period from midnight to 5 a.m. And we're going to give our answer to the nearest whole number. So we're going to write it on the answer booklet. So they provided sample answer booklets. Mine say sample. Yours do too. It just didn't print very dark. But I wanted it to look exactly like what you're going to see. So if I want to find the number, how many fish entered, and I know the rate at which they enter, do you guys know what to do? It's going to be an integral, right? And then we are not going to write out what E of t is, because that will waste time, and it's possible you might mess it up. So we're just going to call it E of t. We are going to put it in parentheses, and we're going to put d of t on the outside, and we're going to round to the nearest whole number. So you guys try that, see what you get. And then we're just going to round to the nearest fish. So it should be 153 fish. Now, I would write my answer. I don't know if they want to see it, but we want to practice perfectly at this point. So I would just say something like 153 fish. And then I'm going to quote the problem. Enter the lake over the 5-hour period from midnight to 5 a.m. All right, and then I'm going to go back and look at B when you guys are ready. Okay, B says, what is the average number of fish that leave the lake per hour over that same 5-hour period? All right, average number. What are we going to do for that? We don't have to do rate of change, just kind of like rate of change. It's the average value formula we just talked about, right?
Oh, the one of.
Yeah, 1 over 5 minus 0 from 5 to 0. And then this is the leaving function, so it's going to be L of t dt. Now, if you just do 1/5 in the front, I think it's fine.
So is it from 0 to 5 or 5?
Oh my goodness, it's from 0 to 5. I don't know why I did it that way.
And then we can just put 1/5.
I think you can. Now don't forget that we did put L in Y2. I think that might be one of the things that might hurt you a little bit with it being all digital, or with your question being digital, because I think that stuff that you would maybe write on the paper that would help you. You can always write it on your test booklet where you save stuff. All right, did you guys get what I got? Okay, how many decimal places do we need to be accurate to? 3. You can do 4 if you want to. And you can truncate or round, which is going to be the same in this particular question.
I got a negative.
Did you do 5 to 0 like I wrote the first time? Instead of 0 to 5?
Oh.
I wrote it wrong, sorry. All right, and then again, I would just take a minute. You don't have to write a big long explanation. They're not asking you to explain. But it is good to present your answer, and I would, again, quote the problem. Right, I would definitely use units there too. Now, if you're super rushed for time, you don't have time to write all that. Up here, definitely give fish per hour. It's best to write the sentence, but like I said, if you're just like trying to get it all in, give units on your answer. All right, and then C. C, it's been a while since we've done. So at what time T for 0 to 8 is the greatest number of fish in the lake? And we are going to justify our answer. And we'll think about that. So when you're wanting the greatest number or the smallest value, you're wanting to find the absolute max and the absolute min. Do you guys remember what we used to find those? We use the candidates test.
Oh, no.
And what are your candidates going to be? There's two different places. Well,
Zeros and relative extreme.
the endpoints of, so definitely in this case, 0 and 8, the endpoints of the interval. And I think what you're saying, so we want to know the relative, or use the relative extrema. That is when what calculus thing is 0. The critical numbers, when the derivative is 0. So we need the critical numbers. Okay, but what is, for this particular situation with our fish, what is going to be the rate at which the number of fish are changing? Y3, which would be, so it's going to be E minus L. All right, so unless somewhere on your paper you're saying Y1 is E and Y2 is L, make sure when you're doing it you use E and L.
Is it an interval that we got?
In a second, when we use our candidate, when we do the test for the candidate. So for now, we're going to say that E of T minus L of T represents the rate of change in the number of fish in the lake at time T. So a critical number is going to occur when that, because that's our rate of change, is 0. So let's find when that happens. So E of T minus L of T equals 0 when, now, E of T and L of T are crazy equations, but it doesn't matter because we have a calculator, bless you, that figures out stuff with crazy equations super easy. Now, I would recommend, because right now I have 3 functions, I would turn 2 of these off. So you can turn them off by hitting enter on the equal sign so it's not darkened. So when I look at the graph, it's only going to be my rate of change function. And we're just going from 0 to 8. So I don't know what my window is. I did some stuff last class. So I'm just going to go from 0 to 8 on my X. And Y, I'm just going to go from negative 10 to 10. I'm not 100% what this is going to look like right now. And then let's see what happens on the graph. All right. And then I have 1 0 in that section. So I'm going to have one critical number. Do you guys know if that's going to be a relative min or a relative max?
I want to say min.
So this is where it's 0. The derivative or the rate of change is changing from positive to negative. So the function is changing
it's a
from
max.
increase. So it is a max. So it could be one of our answers here. All right. So let's find where it is. So second trace 0. I cannot see my little guy. There we go. All right, so we're gonna hit enter on the left and right, and then enter one more time. Okay, now this is what I would do if I was you. So I would definitely jot that down when t equals, and go to all the decimal places. Now I really wish the calculator would find a way for you to like store that in for a number or for a letter. I don't think it does.
For X.
Well, you could,
From here?
well, you could go back and then put Y3 of just kidding.
Yeah, I know I can store it. We're going to in a second. I want to be able to store it without retyping it, is what I was saying. But it's okay. We can retype it.
That's with that entire font section.
I'm just trying to find ways to save you guys as much time as possible. So I'm going to take that to all the decimal places, and I'm going to store it for A. And I'm going to tell the people who are grading my test that I did that. So I don't have to keep writing it in my integral. I'll do it in a second. It's just going to make it, for me, it would make it a little easier for us. All right, so now we're ready to hold an election. And we need to jot down what our candidates are. So our candidates are going to be times. And what we need to know is the number of fish in the lake at that time. All right, now we already said a second ago that the endpoints of our interval are going to be candidates, and then any critical number in this case is A. That's fine. Okay, so if I know the rate of change of the number of fish, and I want to find the number of fish at a certain time, this is where we're going to do integrals. Now this first one, I mean, it's kind of redundant, but we're going to go from 0 to 0. Do you guys already know what that's going to be?
0.
Yeah. Now, sometimes it'll say at time 0 there were 100 fish or whatever. This case, that is not one of the things. All right, and then for time A, we're going to go from 0 to A. All right, and then we can let our calculators do that. And then remember, we did the E minus L in Y3. All right, and then my last one, I'm going to go from 0 to 8. Oh, there's one. All right. And then we are justifying our answer. So that's all work. And so to do your justification, you're going to need to say something like, by the candidates test. And then we're going to answer the question. And so, what time? We're only looking for the time. We're not looking for the number of fish. We're just looking for the time. So the time is this, whatever we had for A. So the greatest number of fish. Okay, sorry. So by the candidates test, the greatest number of fish in the lake is at T equals, and we can just be 3 decimal places here. We probably could just be 3 decimal places other times, but we try not to round it to the end. And then I'm going to say hours since midnight. I think it's probably fine if you just say 6.204 hours, but we're practicing perfection right now. All right, and then part D is a tricky question. And so it asks, is the rate of change in the number of fish increasing or decreasing at 5 a.m.? So how do you decide if something is increasing or decreasing using calculus? The slope? What do we use in calculus that's the slope? Derivative. So if the derivative is positive, that thing is increasing. If the derivative is negative, that thing is decreasing. And so we want the derivative of the rate of change. What did we say the rate of change was?
E of t.
Right. So the derivative of E of t minus L of t is just E prime of t. We're not going to use t here. Minus L prime of t. That is the derivative. What is our moment here? What is our t? Just at 5. All right. And again, if it's a calculator question, you better not find the derivative by hand. If it is a calculator question, you better not find the integral by hand. Do not do it.
Guilty.
All right. So we have E of t minus L of t in y3. So I want the derivative of that at 5. So we're going to go alpha window 3 in terms of x of y3 at x equals 5. All right. You will get a point for telling what that is, even if you answer the rest of it wrong, I think. Oh, and I meant to say this on the previous one. A lot of times when you have to do a candidates test, if you just identify the candidate, it's a point. So if you know, but you don't know how to figure out how many fish, but you know what the candidates are, write them down. Write down what the candidates are. Okay, so what do you guys think? Is the rate of change of fish increasing or decreasing at this time? Decreasing. And we have to explain. So your explanation doesn't have to be formal. It has to be just kind of what we just said. So because E prime of 5 minus L prime of 5 is less than 0, the rate of change in the number of fish is decreasing at 5 a.m. Oh, that's good. Oh, let me move that out of the way. Sorry. All right. So what questions do you guys have about rate or accumulation FRQ?
I hope they put one about snow falling on the driveway.
That would be cool. They probably won't since I've done that before. They've done them about bananas, gravel, all kinds of stuff.